record. All right. So boxes and devices today. Let's go. Where are we? Here. Okay. So Canadian electrical code determines the amount of wires an electrical box can hold based upon the following things. Here is a little picture that was I inherited from well, the course when I took over some years ago. Well, that kind of it seems like it's almost like surreal to have those pictures like that, but you'd be surprised. This picture, I don't think this was posed. Sometimes what happens is when you go along, you're going to discover all kinds of different funny, no, not funny, excuse me, not funny things. And I have done it. You just stumble onto something that you just have to take a picture, and I think this was probably one of the situations. All right, now this is by no means this is well, actually this is not safe. All right, and it's not legal. Right, so we're just going to take a look at some of the criteria that when it comes to, well, dressing up wires and fitting them into device boxes. Remember when during the lab, when we are talking about, well, how long the wire should be. It should be 150 millimeters or 6 inches from where the wire leaves the connector inside the box to the point where the wire is terminated. So minimum 6, and I always say 6 to okay, so his voice is not so loud. Okay, let me just take a quick look at the. Sorry, thank you so much. Um, Audio settings. Check test 1 2 check. Check testing 1 2 check. Check testing 1 2. Right, is this better? Okay, thank you so much. All right, I just adjusted the levels there. I had some problem with some of the noise, so okay, let's keep going. Thank you for that. So when I say that the wires should be about 6 to 8 inches, so no less than 6 inches or 150 millimeters, but try not to make it like 25 inches because you're still going to have to pack those wires into that device box. All right, so that's what we're talking about here, and it's not just on the basis of, well, be careful not to overload the boxes. There's certain rules that we go by. So one thing is saying be careful so you don't overload the boxes. The other thing is here's how you do it. All right. Okay, so CEC determines based on the following things: total volume of the box, and we are specifying this thing in milliliters. Well, if somebody doesn't know, well, what's the bottle of Coke or ginger ale, the big bottle? A liter and a half or something like that. A milliliter is 1,000th of a liter. All right, so it's a unit of volume. All right. Now, size of the wires as well in American wiring gauge, and the type and size of the device in the box. For example, a switch is going to take less space in the box than the GFCI. And GFCI stands for a ground fault circuit interrupt. That switch or that device, that receptacle, will have some additional circuitry that is that needs to make things work, and of course that circuitry is going to occupy some space, so that device is going to be a little bit bulkier. So if you have a device that takes more space inside the box, then of course you're going to be able to put less wires in that box, or you can get a bigger box. There's a problem, here's a solution. The number of the wire connections also makes a difference. All right, next slide here. Come on. So the next slide, yes, it is. All right, so here's the table 23 of CAC, number of conductors in the boxes. All right, well, let's see what happens here. Boxes, dimensions, and trade size. Here's octagonal box, square box, round, and well, device box, which is rectangular shape type of a thing. All right, so then later on we're going to take a look at how some of those boxes look like. But here, let's see, octagonal box, 4 inches by 1.5 inch. Okay, now octagonal box, so it's a 4 inches is dimension one of the sides, and the last dimension gives you the depth. So this is in inches. So I know, yeah, in Canada we're supposed to be doing things in millimeters or meters or anything is metric, but the reality is that whether or not we do both systems, imperial and metric, and don't ask me why. It's just how things have settled, and that's the way it is, right? Square box also. Notice that octagonal box and square box, only one side is mentioned, because, for example, in the square box, all sides of a square are equal to each other in length. So you only have to specify one. It's a square box, 4 inches by 4 inches by 4 inches by 4 inches, right? So there you go, 4 inches one side. And here is the depth. I wish I was able to get rid of that pop-up that goes by the mouse. That's very annoying, but so okay. Now here's some other so here are some of the dimensions, and over here it's the milliliters, volume in milliliters. Now this one here, see, on this side of the table, it just gives us it gives us the dimensions in inches. And move to the next column, and you get the dimensions in inches or milliliters and cubed and inches cubed. All right, so figure that out. Oh, go figure. All right, so here are the gauges and how many wires can you fit in some of the boxes. So, for example, let's look at the round box. So here's the diameter of the box, 4 inches and ½ inch deep. Okay, and that should take 81 milliliters or 5 inches cubed. Now, maximum number of conductors per gauge. Okay, so you can, in that one there, you can fit 3 14 gauge wires in there. Wow. Or you can fit 2 12-inch. You can see the gauge goes down, which means the thickness of the wire goes up, and so on. You can only fit 1 8-inch, in a round box, 4 inches by half. That's not a lot of wire you can fit there, right? Same thing with the pipes. I'm going to digress just a little bit. If there's any people who do data, well, we're going to talk about that, some of the data stuff next semester. If you have it with me, then it's just, in pipes, it's a 70% fill. How many data wires, Cat5e data wires, can you put in a ½ inch pipe? 1, all right? So, excuse me. So here's the different device boxes, and here's device box 3 by 2. See, there's 3 dimensions here, right? 3 inches by 2 inches, and by 1.5 inches deep, or 3 by 2, 2 inches deep, 2.25 inches deep. See, 3 inches deep. So you have the same size of the box: 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right? Yeah, boxes. So it's the 3 by 2. So now the second one here, the 2 inches, that tells us this is a single gang box, and we'll talk about what that means. Right? This will rarely change when it comes to a device box, like a utility box. Now here's another one, 4 by 2, right? So this is bigger box, one way. It's not a double gang box. It's still a single gang box. It's just a bigger. Very rarely you're going to see those 4 by 2s, but most of that we're going to see 3 by 2 by 2, or some of that 1.5. You can still see some, but these are called device boxes or utility. This one here is a classic 3x2x2 classic utility box. Okay. Or sometimes it's called a handyman's box. And here is the number of wires you can put in. All right. And so on. So that's how you read this table here. Now, another one here, size of the conductor, usable space required for each insulated conductor. So here's another thing. If you want to use some of the, you want to use this information in some of your calculations. 2 liters. Oh, thank you, Charles and Jordan. 2 liters. Yeah, the big Coke or ginger ale or 7-Up, whatever bottle is 70. So that gives you some comparison or some visual on what milliliters are. 1 liter is 1,000 milliliters. Okay. All right. Back to the table here. Table 22, spaces for conductors. Okay, so this is how much each conductor will take. Needs to be in the amount of milliliters that the conductor would take. So size of conductor in American wiring gauge. Gauge 14 will needs 24.6 milliliters of space, and gauge 12 and so on and so on. So that's how much space they take up on the in the box, right? Not going to spend too much time on this table here. All right, now when we say how many wires can we fit in the box, but we're just going to get you started on, and then you can continue with your code class, because this is not a code class. However, we mentioned some things in the code. So we can say how many wires can you fit in a box, but excuse me, we need to be able to tell you, well, you need to know what is considered as a wire. No stone gets unturned. All right, so what does this one says? Maximum number of conductors in a box. Boxes shall be, and this is how kind of like a lawyer type of language you're going to read. I'm pretty sure you noticed that already when you were studying code in the other class. All right, so boxes shall be, here shall, words like that, shall be of sufficient sizes to provide usable space, blah. Here is the whole preamble, okay? Let's read that preamble. Boxes shall be of sufficient size to provide usable space for all insulated conductors contained in the box. And here you go, subject to the following. Ooh, all right. All right, a conductor running through a box with no connection therein. I love these words in trades language here, but that's the way it is. A conductor running through a box with no connection therein shall be considered as one conductor. All right. Let's read that again. A conductor running through a box with no connection. So the wire runs through a box. Let me fire up my board here. There's a little tiger here. New file. Let's go. Create a file here, right? Three by four, 5 by 7 by 5. Yeah, no, 55. That's what we want. All right. So here is a box. Let me just choose some appropriate color here so we can be seen. Let's get a pen. That's good. So here's a box, device box. Okay. And here is a wire going from wherever it meets the connector here, and there's another connector, let's say here, all right? And the wire continues through that box and goes somewhere else. You're going to see situations like that. So what does the code say about that? A conductor running through a box with no connection through the box should be considered as one conductor. So that wire is considered as one conductor in the box. Okay, we're not going to go through the whole thing. No, don't worry about it. I'm just starting you up on this. Each conductor entering or leaving a box and connected to a terminal or a connector within the box shall be considered as one connector. Right? So each conductor entering or leaving the box and connected to a terminal or a connector within the box. Okay, so let's say we have another box here. Here's a box, and here is our duplex receptacle. Here are the screw terminals here, So there's a wire going into the connector. This wire is considered as one. Here's another one going, let's say here, that's a very surreal kind of a situation, but just to get the picture. So this box has two wires, right? If this wire here run through the box, again, there's another wire here. It runs through the box. So now this box has 1, 2, 3 wires. Okay, now let's see this here. Just take a look at this. Let me get an eraser. I'm gonna interrupt this wire here. What does it say? A conductor of which part leaves, nope, that's not it. That's not what I want to show. Let's say we're going to make a connector here. So now, if this wire was continuous, so we had 1, 2, 3 wires, right? Now, each wire, let's say there's a wire knot connector, okay? And those wires are connected in this here. You cut the wire and you join it again. So now we have 1, 2, 3, and 4 wires. See that? Because it says each conductor entering or leaving a box and connected to a terminal or a connector within the box shall be considered as one connector. So that's how we made 2 wires out of 1. Conductor of which part leaves a conductor of which no part leaves the box shall not be counted. Right? And then there's some well, let's take a look at the C part here. A conductor which part leaves no box. So if we have another, let's see here. Get the eraser again. Eraser. All right, we got eraser. There. Okay. Get a pencil and get another connector here. Another wire knot, or sometimes called moret connectors. Now here and here. The number of wires has not changed. Right? We still have one, 2, 3, 4 wires in this thing. This wire that no part leaves the box is not counted as wire. It's just the way things are counted, right? So we say here, this is a conductor which no part leaves the box shall not be counted. And number 18, 16 gauge fixture wires supplying a luminaire mounted on the box containing the fixture's wires should not be counted. All right, what does that mean? What am I doing here? New, yeah, create. There we go. So here is a, well, light fixture, all right, with a bunch of lights here inside the light bulbs and whatnot, right? And it has a little pipe. Inside those pipes, inside that little pipe, mounting pipe, are wires, and here is the light fixture, and it has wires. And let's say that is mounted right on the box. That is mounted in the ceiling somewhere. These wires that are in the box are not counted as wires. So they're wires, but they're not, right? It says fixture wires supplying a luminaire. Luminaire is, well, here, all right? That's a luminaire, a light fixture. Okay. Ah, touch it twice. And these are usually 16 gauge wires supplying the luminaire mounted on the box containing the fixture wires. And those are not, these are not counted. And we could spend, well, but that's not a code class. So I'm just going to stop right there. This is how we're counting the wires. And there's some more conditions to that, right? In the boxes. Here. Now, let's take a look at some of the boxes. Here's a single gang box, single gang device box, right? Now, this one here is 3 by 2 by 2.5. So 3 by 2 by 2.5 deep. The last dimension gives us the depth of the box. And why do we call it a single gang box? A single gang box. It's because this one here is 2 inches, this dimension. So that's a regular light switch type of a receptacle box. If it were a double gang box, this dimension here would increase, so it would be wider, just like that, right? And you could have triple gang box, quadruple gang box, and you can go on ganging those boxes, right? But this is a single gang box. It will accommodate a single receptacle, single light switch, or whatnot, right? That 2 inches tells us. Now, how many it can contain, for example, 8 14 gauge conductors. 14 gauge is pretty much the most common. If it were 12, it would be less. Take a look at the code, right? Now, single gang device box. Most common uses, sizes and uses. Single gang box, 3 by 2 by 2.5, and 3 by 2 by 3. Right? So if you had just a regular duplex receptacle or a light switch or whatnot, it's okay to use 3 by 2 by 2.5. Now, because GFCI grants fault circuit interrupt has some additional circuitry, so the receptacle is bulkier, and we will talk about, we'll take a look at some of that. Actually, in the lab, remind me, I will just pull it out of the box and show you the differences between the GFCI and regular receptacle. You will see what the differences are, right? So then you need a deeper box. See, the last dimension tells us the depth of the box. So 3 by 2 by 3, single gang box. You need to have that if you want to use GFCI. Front face of the box extends. Okay. What's this? Okay, let me read this thing first. Front face of the box extends 1/2 inch in front of the stud or for the drywall. What does that mean? It means, it means that when you have the timber framing, for example, timber framing, here are the studs in the wall. Right? So here is the wall and here are studs. And so on. They keep going. That on top of the, where the studs are, there's going to be a drywall. I can't draw straight. So here's going to be a drywall. So the room can be nice. Okay. Here's the little cubby hole room. All right. Now that size, the dimension, the thickness of the drywall right here is 1/2 inch. So if you look at from the side, there will be a stud from the side. When we mount the boxes, the device box, we're going to extend that box 1/2 inch. So that will be the looking from the side here. We're going to extend that box over the stud 1/2 inch because the drywall thickness is 1/2 inch. And when the drywall goes on the studs, it's going to be what we call flush with the box. So things are nice and beautiful. Right? So that's what that thing means here. Front face of the box extends, and there are some helping things, helping guides that we use when we're mounting boxes, and is going to be shown in the next few slides quite clearly. Right. So front face of the box extends in front of the stud for a drywall. Yeah. All right. See. There it is. Next slide. There we go. How do I zoom in? There we go. You see, here's a stud, and this box, when it's mounted on the stud, it extends. And there are those little lips here that you can put against. You don't even have to take any measurements. Right? What are there are some other helping lines. There's one. What does this line here? Because some of the dimensions would be specified with the OC, so many and so inches of the floor. OC, so it'll be on center. So somebody marked the center here. Okay. So here are those lips here. You put it against that, and that gives you exactly 1/2 inch. So when the drywall goes on top of the stud, it will be nice and flush with the surface of the box. All right. Now, here we have a 3-way switch, and over here we have a 4-way switch. We'll talk about what those are as well in the boxes. Get zoom to the proper thing. Single gang device box cover plates. We have a couple of different plates here. Now, this is the kind of a ragged type of a faceplate, but for the most part, that's what it looks like. And from then on, you can get nice plastic PVC Decora type of thing, but the shapes are going to be pretty much the same because they have to accommodate the footprint of the device of whatever it is, right? So here is, and both of these are single gang device box cover plates. This one would be for the duplex receptacle, and this would be just for a switch, be it a single pole switch, 3-way switch, or 4-way switch. The shape of the switch, I don't want to use the word footprint, but you can say that as well. All right, well, here's a double gang box. See that? See the difference? Single gang box, double gang box, or 2-gang device box, double gang. See that second number changes into 4. So here's 3 inches, this one stays. And here's 1 gang, single gang, another single gang, joined together, and that makes it a double gang box. So that's 3x4 by 2.5 inch. One of the most common one. That thing can fit 16. You can put 16 wires in there that are 14 gauge. All right, here is a 4-inch square box. So here's a 4-inch by 1.5 inches. All right. The last dimension tells you the depth. And if it's a square box, you only have to specify one side because, well, it's a square, right? Okay. So this one here, you can put 14 wires inside there, this box, that are 14 gauge. And what this one says, not often used in residential wiring, exception cable connections with no devices. So in other words, this thing here in parentheses says that it's not often used, but I don't know, sometimes it is used. Yes, it is used sometimes in the residential. So mostly you're going to see that in commercial to mount some sort of devices. However, if it's used in the residential, then mostly it's going to be used as something that's called a junction box. So a bunch of wires come in and they would be distributed. Maybe there's one feed wire feeding the box, and from that box there will be other wires coming out feeding different devices. And once this thing is done, just a blank cover plate is going to be put on, and that's it, i.e. junction box. Here's an example of a junction box. 4-inch box used as a connection point for a circuit. Let me zoom in just a tiny bit here. What can we see here? Well, there is a feed cable feeding the box with service. It's a service conductor. Service conductor means power is being delivered to the box. Now, over here, this cable can go to maybe a light switch, and this cable can go to a light, for example, right? Or this cable can go to one of the receptacles, the other cable can go to another, but it's probably, from what it tells, that could go to a switch and that could go to a light. Could be, right? All right, so, and there is no device mounted here. This one is used as a junction box to make things pretty, and so they don't blow up. Right? So they don't blow up. Excuse me. All right. Now, here's the triple gang boxes. We're going to go up to 27 gang. No, just kidding. So here's the triple gang device box. Now, see here, 2 inches, 2 inches, 2 inches. We just keep going by 2 inches. So here's 3 inches, because this one here is always 3 inches. That's not going to change. There's a 6 inches by 2.5. And this one here, you can have 24 wires that are 14 gauge. Okay, so here's the 4 gang box, all right? Now, plastic, got it? 4 gang? 1, 2, 3, 4, 4 gang box. We see those all over the place in our school, in our classrooms. Those boxes are used for the multiple light switches one beside each. Right. Now, plastic 4 gang device box. The device boxes are not only used for electrical purposes. Excuse me. Yeah, there we go. That was a good sneeze, sort of. Plastic 4 gang device box. So there, the device boxes are not only used to accommodate electrical devices. There could be some other devices like signal for cable TV, for telephone. Everything needs to be in the boxes. Although sometimes, I'm going to say this once, and I'm going to say it probably many more times. Whenever you're doing data wire, try to have this thing without the back box or device box. Just make a cutout in the wall, excuse me, and mount that. And I'll tell you why. Everything else, you are safe to use the box. And by saying the word safe, I don't mean from the health and safety point of view. It was just a figure of speech. So there are different device boxes and different faceplates. This would be, well, the wall behind a flat screen TV. See that? Because flat screens TV, they want to be as flat as possible towards the wall. That's the So we're using the space cavity in the wall to go inwards. And here we can have power. What do we see? A coaxial cable, a telephone connection, a regular POTS. POTS stands for plain old telephone service. You're going to see less and less of that, although it's still, so that probably is for a DSL signal or something like that, right? And over here we see some signal connections and a couple of loudspeaker connections, and all that nicely compacted. If you're interested in installing things like that, so this would be maybe well, almost like just a regular living room type of a setup in the modern housing right now. Or you can get a little bit more complicated if you want when you're doing something like a home theater situation. Then if anybody is interested in that kind of stuff, electrical or telecommunications or communications part or infrastructure, data signal infrastructure, talk to me as well. I will, if you're interested in that kind of stuff, I can put you in the right direction. I've done it for over 30 years, right? So here's another well, sometimes when you walk into a distributor, and if you want to know where those distributors are, because the distributors will not sell to public, they will sell to people who run their own business or buy for a business. And that's where the cool toys, you're going to see some of the really coolest stuff on the shelves when you walk in the store. And I can tell you where to go, and if you want to sign up to have your own business, or if you work for somebody, there's just going to be that much more that you can offer. I can tell you where those are. In those distributors, you can walk in, right? You can take a look, but you can't buy if you don't have a registered business. And I can tell you where those are. They're pretty much in GTA, Greater Toronto area, so Brampton, Mississauga, that stuff. But they exist, and they're the coolest stores, at least what I think. All right. Gangable boxes. Gangable. Gangable box. Gangable boxes. Okay. That's the way it was written, so I'm going to try to read it as without being too funny. All right, so some of the boxes are it. Like those utility boxes, those single gang boxes that we already played with during our lab. These are it. These are not gangable boxes. That's it. There's a single gang box, and that's all it will ever be. But some of the boxes are gangable. All right. What does it mean? You can disassemble it partially. So you can take this wall off, and you can take this wall off, put those things together, screw them together, because that's how they work, like Lego. And you get a double gang box, and you can keep adding, right? So there you go. When you were kids and you got to play with the Lego blocks and whatnot, this was not for fun. It was to get you ready for this, so you could be in the workforce. There we go. Now, it is a good idea to have a stash of those in your working truck or working van as the inventory, because sometimes when you're in the pinch, you can combine many of these to make it a mini gang box, as many gangs as you want. All right. But if you are doing a large installation, then you would, like, for example, if you're doing a school when you have a bunch of classrooms with those multiple switches, just like we have, of course you're not going to waste time putting those things together every time you're going to order. You're going to order the ready amount of boxes that are supposed to have the certain amount of gangs, right? But it's always a good idea to have these, because if you're in a pinch, but I'm repeating myself, right? All right, so these are called gang-about boxes. And that's how you have two single gang boxes, and if they are gangable, see, there are those screw connections there. So this wall was taking off, this wall, and they were, and they can keep going. So something like that exists, right? All right, what does this one say? Removing outside panel. Okay, you can read that, but I just told you that. All right, now, gangable boxes. Used mostly for adding devices. Oh, no. Now, cable for. All right, what does this here? What is this? Remember here, for example, a box is mounted on the stud. You can mount the box. As we mounted those boxes, excuse me, in our lab, for simplicity, we just mounted on top of the stud. Okay, but for the most part, in reality, you're going to mount them on the side of the stud with a 1/2 inch extending. And if it's a brand new construction, you have the freedom of finding the studs and mounting them on the box, and the drywaller crews come in and they install the drywall. All right. Here, all right. But if you have existing installation, sometimes you're going to be required to put a switch or a device where it is going to be in the middle of the wall. So there will be a stud somewhere here, and there will be a stud so between the studs. For that, it is also a very good idea to have a huge stash in your van with something that's called F-clips. Right? With the use of F-clips, and that's how they're being installed, you can mount the device box right onto the drywall itself. So it's good for the retrofit. Retrofit means it's already some of the structure is already there, and you're adding on or replacing some of the devices, or additions when you have a situation that you need to install one more device box in the middle of the drywall, and you don't want to make this thing look like a construction site, right? You're just adding a device box. So these are the F clips. Now, F clips, did I put a link here? No, I didn't. I'll show you next time I see there's about a minute and a half or maybe less than a minute video on how to use those F clips. They're the neatest things. It's a good idea to have a lot of those. They don't take much space in your van. Just have a box of those, and once in a while when you run out, just replace it, because you're always going to be using them sooner or later. That also a box of something that's called smash plates is a really good idea to have in your van all the time. And besides that, I already told you that it's a good idea to have those gangable boxes. All right, common devices with gang boxes. Well, there's a single pole switch. A single pole switch is just a single pole. Single pole switch. My pencil. Here's the conductor. Here's the terminal of the switch. Here's the pole. Here's the other terminal of the switch. You can close it or open that switch. Single pole, single throw. Yeah. Now, here is a single pole, double throw. Single pole, single throw. Single pole, double throw. Also known as three-way switch. You can also have double pole. All right, what would that be? This would be a double pole, single throw. And that's how we name the switches. Right? So here is a single pole switch used as one of the simplest things that we can do for a light switch, basic light switch, or a bathroom fan switch. Right? Duplex receptacle, we already have played with that in the lab. Everybody had exposure to this. Now, how much time do we have? Okay, you know what? Just going to go on this one here, and they're going to stop. So here is duplex split receptacles. A duplex receptacle has a brass side tab that can be removed in order to make a split receptacle. Most common uses: countertop receptacles in the kitchen and split switched receptacles in the living room spaces. Here is, all right, so here's a duplex receptacle. What makes it a duplex? What makes it a receptacle? It's a receptacle that you plug things in. What makes it a duplex? It has two receptacles. So it's a duplex receptacle. Right? Now, there are screw terminals associated with each prong of those. So here is the screw terminal that is connected to this prong. Here's a screw terminal that is connected to this prong. Okay, and here is that tab that joins them. So if you have the out of the box, when you buy that, those tabs are in place, but you can just grab those tabs and twist them out or just break them off. So once you break it off, here is a situation where the tab is broken off. You see here? It's a poor job of breaking it off because things are too close. I would just clean it up a little. But now this screw terminal goes to this hot prong. This screw terminal goes to this hot prong. And here is a neutral wire that goes to the other side, to the long prongs, and the top there is not broken off. Right? So if there's electricity flowing, it could go from the black hot through the receptacle here and return on the white. Or it could go through the hot red and go through whatever the receptor that is plugged in and come back again on the same whites, which makes this white neutral the most busy conductor of them all. Because this one on can be on independently of that. And of course, here's the bonding wire. Now, I left it on purpose, this picture here. What is wrong here? There's something seriously wrong that should jump at you without even me saying that. When I brought, by the time I brought this picture on the screen, you should cringe. You go, you should notice this right away. What's wrong with it? Pinched insulation. Thank you. There we go. All right. What happens when we have pinched insulation? We are not making, there's a possibility of this connection be a partial connection. And that can cause all kinds of problems, including starting a fire. Right? So what happens here? We have two separate, so this black wire will go to one of the circuit breakers. This red wire is going to go to another circuit breaker. And usually they would be, instead of 15 amps, it will be 20 amps for split receptacles. Where do we use them? Well, kitchen countertops, when we need a lot more power than in other regular receptacles. In the living room, you plug in a TV or a vacuum cleaner or something like that. This here, if you have a countertop receptacle, in the morning, kitchen is the busiest time for the whole family. So there's toasters going on, there's blenders going on, coffee makers and whatnot, and circuits can be overloaded. So that's why those, to solve that problem, split receptacles are being installed and the amperage is upped. But it can be 15, but 20 is common for the kitchen countertops. And so those wires can be put, each receptacle can be, so if you have 20 amps, you can have 20 amps going through here and 20 amps going through here, all together in that spot. You have the possibility for 40 amps in terms of like additive power, additive current consumption needed by multiple devices plugged in here, right? As in otherwise, if this was not a split receptacle and it would be like 15 amp, the whole thing would be able to provide only 15 amps. See the difference? All right. Okay. And also, what these are being used for is well, in the living room. For example, the top one can be just a regular receptacle to plug things in, and the bottom one can be used to power up like a lamp that stands in the living room, and that can run through a single pole switch, so you can power on and power off this particular bottom receptacle with the light switch that is, well, or the single pole switch that is mounted on the wall, so you can turn on the like a floor lamp that's plugged into that one there, right? Yes, it's being used. Right. Okay, so this is it for today, and next time we're going to see each other is in the Z building in class in person. And happy almost Friday. I know it's Monday, but you know the story, you know the drill. All right, thank you so much, ladies and gentlemen, and I'll see you next time when I see you. Bye.
Thank you.
Thank you.
Thank you, sir.
Hey, if I
Thank you.
always trying to find the button to stop the record. Okay, bye.